Our data measurements were recorded during the months of June, July, and August of 2011. During these months, there were many days of full sun throughout the day where outside temperature exceeded 100 degrees F and solar irradiance exceeded 1,000 watts per square meter. The solar irradiance for days of prolonged full sun peaked near solar noon, which occurred at about 12:45 p.m. in Las Vegas that time of year. For the purpose of analysis, 10 days were chosen during this time period where the solar irradiance exceeded 1,000 watts per square meter for a prolonged period of time. Although wind speed could not be controlled, these days were also chosen because of low wind. This resulted in 5 days in late June and 5 days in early August. For each of these 10 days, the temperature data were analyzed for the period of time of day where the solar irradiance was greater than or equal to 1,000 watts per square meter. Depending upon the day, this resulted in elapsed times of 3 hours and 5 minutes to 2 hours and 15 minutes. The rise above outdoor temperature for each test sample and for each of the 3 thermocouples was averaged at 5-minute increments. An analysis of variance for the 3 thermocouples typically showed a variance of less than 1 degree F, except for the tray cable samples, where the variance was greater because of the orientation of the 3 thermocouples around the circumference of the cable. For that reason, the maximum temperature of the 3 thermocouple readings for the tray cable was used for this test sample because of the importance of recording the hottest temperature being experienced by the cable. For each of the 10 chosen days, the maximum, minimum, 90th, 75th, and 50th percentile temperatures were calculated for each test sample at each elevation for the period of time of day when the solar irradiance was greater than or equal to 1,000 watts per square meter. For the accumulated 10 days, the overall maximum, minimum, and averages of the 90th, 75th, and 50th percentile temperatures were then tabulated.